Salam Sejahtera and welcome to the second round of CMCO in Malaysia. So I hope everyone's staying safe. It's quite dangerous time, so I hope you're all wearing a face mask, hand sanitizers, not touching anything in public. And that's the other reason why I'm doing presentation online, because no contact and physical distancing. So my name is Dhipan. I'm a fourth year mechanical materials manufacturing engineering student in Nottingham, Malaysia. I'm doing a master's degree, and the topic for today would be edge computing. So you may ask me, like, where did I come up with this topic from, and like how do I think of this? So throughout the summer, I worked in Hatalega. Hatalega is a glove production company, and there's a factory based in Sepang. I worked there, and during a session with Mr. Kwan Man Leong, who's the CEO of Hatalega, he mentioned about IoT, and he mentioned something that I couldn't really grasp and something that I didn't really know about, which is edge computing. Now I was quite bamboozled. I didn't know what was happening, because he talked about having new computers near with sensors, and it requires maintenance, and it's quite high cost, and how the control and instrumentation department was complaining about it. And then I went back home and I had a look about what edge computing is, about what it does, and how does it affect Hatalega. And I had a look around the factory as well. So when I went back to campus, I thought that's it, that's the end of this topic, but then a couple other opportunities came about. One of this, which is SoFE. I had the opportunity to represent Nottingham, and I represent Nottingham talking about edge computing. I also had the opportunity to talk about this in my advanced technology review module, where we had to present a poster about this. It's quite an interesting topic. It's quite a new topic. Not many people know about this. That's why I find this interesting. I find it interesting to educate people about a topic that not everyone knows about yet. Yet the fact is, it is quite important, and it's important that we all grasp this topic. If not, we're gonna get behind the times. Just like how blockchain was a thing 5 years ago, and just like how cloud computing was a thing 10 years ago. So without further ado, I'll begin my presentation. Now, before I move on my presentation, I'm going to talk about the structure of my presentation. First of all, I'm going to introduce to you about what edge computing is and how it complements cloud computing, and also how it differs to cloud computing. And then I'm going to talk about the advantages and disadvantages of edge computing, and how we can both disregard disadvantages as well as use the advantages to a maximum potential. And finally, I'm going to talk about the applications of edge computing in today's world, especially in a world with COVID. So first of all, why is edge computing relevant? Edge computing, according to a couple of research houses, with a compound annual growth rate of about 37% and a market capitalization of almost $44 billion by year 2027, it is not only there to say that edge computing is going to be just like a supplement, but it will be a prominent feature in the manufacturing industry as well as in our daily lives. Cloud computing in the past 20 years wasn't really something that's big or something that everyone knew about, but now it's so integrated. Everyone knows about iCloud, everyone knows about Google Drive, and everyone to some extent uses cloud computing. Now this is what I predict, and this is what all research houses predict edge computing will be like in the next 5 or 10 years. So let's get to the heart of this presentation, and let me explain to you about this mythical edge computing I've been talking about for the past 4 minutes. So edge computing. What is edge computing? Edge computing is, simply put, a processor at the end of your system's network. So instead of having a processor in a central mainframe or a central network, you're putting a processor or a computer at the literal edge. Henceforth, the name edge computing. Quite intuitive, isn't it? For those of you who want a bit more technical details about how edge computing works, now simply put, edge computing did not come into existence just like that. It came to existence through an evolution of technologies. Now, cloud computing was always there. It was there since 2006, as shown in the slide. But there was always an issue of processing speed, about latency, about how fast we can get the data back. And some researchers, some companies have come up with the idea of cloudlets or fog computing, which would mean bringing the networks closer. Now, what edge computing has done, it has refined that concept to its most limit, and now edge computing is the most optimal solution to having a very high latency period with cloud computing. Now, what latency means is basically the time taken to get your data back. So if I send something to you, how long will it take to get the data back? How long will it take for you to process it? And with cloud computing, you need high bandwidth. That's the other issue. If you're something which is on the spot like edge computing, bandwidth will not be an issue. With fog computing, with cloudlets, something is nearby, you require less bandwidth and there'll be less latency because things can go back and forth even faster with a lower requirement for network. So in this slide, I'll explain to you how edge and cloud computers are fundamentally different by using an example. So let me just start off with a factory production line. A typical factory production line would mean that you're sending data to the cloud computers, which are really far away. The cloud computers could be in a server farm or data farm, which is located in California, in China, in India, or anywhere else. But there is a problem with this. Because it's centralized, because you're sending data all to one point, you will have the issue of bandwidth, where you'll need a stable internet connection to send all this data, and you also need all this data back in time. So you will have the issues of latency and bandwidth. So what edge computing does is it sort of decentralizes this cloud computing. So it will be the support of cloud computers by having an edge computer at every production line. It'll process the data on the spot and send data back to the production line and exactly at the time where it needs to be sent out. It does real-time processing. It gives data back. It can have as many sensors as you want. It can have as many data inputs as you want without having the issue of bandwidth, without having the issue of latency. And this addresses the most major concerns with cloud computing, which is always latency and bandwidth. So this cloud computers and edge computers will work in tandem. And then what edge computers does is it will not only send data back to the sensors and to the systems to optimize the entire process, it will also send some data back to cloud computers. What cloud computers do is they will further find trends and further process it to see the overall pictures of all the edge computers. Because in the end, edge computers are decentralized, which means that every production line, there is one edge computer, but there's only one cloud computer. So all these edge computers will aggregate the data and it will send it to this one cloud computer, and from there it will process data and send everything back to these edge computers for further deliberation. Now, the other example would be autonomous vehicles. Edge computers are key here simply because if you have a computer in your car doing real-time processing, you would not have the issue of latency and bandwidth. You can have all the sensors around you. You can have traffic cones, you can have weather signals, and etc. And this edge computer can process data on the spot. It can make real-time decisions, something that cloud computers cannot do simply because it's centralized, simply because it's far away. So I hope this makes it more clear about how these two computing systems are very fundamentally different and how they do not erase each other, but more of complement each other, and how they will push and extenuate each other's advantages even further and disseminate each other's disadvantages even further. Now, on to the core of my presentation here today. What are the pros of edge computing? What advantages does it bring to society, businesses, and all operations around us? There are 5 main factors. Now, the first one would be overall security and reliance. Edge computers, as I've stressed throughout my presentation, it is decentralized. There are multiple edge computers. What this means is that your data is not necessarily in only one computer, which means that if it's hacked, all your data is gone. Edge computers will effectively aggregate data, which means your data is spread over different computers. And then it filters out data and sent to cloud computers, further reducing your risk. So what happens is, if a hacker were to hack one single computer, whether it's an edge computer or a cloud computer, he would not be able to get your entire data information. He would not be able to get every single thing that's personal or things that may harm you. As we know, in the past few years, big companies such as Facebook, Instagram, a lot of banks and dating sites, and there have been a lot of issues with that. A lot of personal information have come out, a lot of relationships have been destroyed, a lot of money troubles have come, a lot of scamming has happened simply because data sites with their cloud computing are not able to secure personal information enough. And edge computing comes in and says, you know what, I can aggregate data, I can filter data, and you do not need to handle every single thing. This makes it safer for both of us. Now, the second thing would be the interoperability between legacy and modern devices. Edge computing works with anything. As long as you have a sensor and receiver, it works. Moving on. Edge computers are faster, they do not require a constant bandwidth, and they're reliable. What this means is you do not need a constant internet connection for it to work, something that cloud computers need. You can have a car running, an autonomous vehicle running, without relying on constant internet connection to make sure that your data is being processed and comes back to the car. The edge computers, which is on the site, it would effectively reduce the amount of bandwidth required, the amount of data being transmitted to cloud computers, and you're only transmitting data that you actually need to transfer. Anything that's key, that's real time, it's being processed by edge computers on the spot to provide you real time data, real time solutions, and real time effective solutions that can help your business or your applications. And I'll further elaborate about this in my application slide. Moving on. Edge computers are also cost effective. How? By having low latency periods, which will mean that you are monitoring and you're changing data and scopes and different parameters for machines on the spot. This would mean that you are making systems more effective. This would mean that you're saving material costs, you're saving costs on all these things that don't work. I learned this during my internship in Hatalega, where they have simple machines which are modulating, and this saves almost half the cost, simply because humans and normal computers are not able to do this. They're not able to process it in real time and not able to give you proper solutions in real time. Edge computers are there to process it in real time and give you data and solution on real time. Cloud computers will be too slow. Data that goes there, comes back, it'll take too long for your process, and by the time it comes back, the time has changed. The input has changed, and you need a new solution to the issue. So this is why edge computers brings about a lot of pros to our society. Now, not everything's a bed of roses. As with any other technology, as with edge computing, there's always cons to it. So, edge computing has 5 main cons. Now, the first one would be the partial or incomplete processing of data. Because data is being aggregated and because data is being filtered before it's being sent to cloud systems, there is a possibility that data might be skipped and you may not be able to see the overall trends after the cloud system has processed it. And because of this, you may not be able to process and analyze data properly. However, this can be easily fixed simply by trial and error, because you need to know what data is important and what data isn't important. By including more or less data, you can roughly figure out what data needs to be sent to cloud systems and what data can be thrown away and what data can remain with edge computers. Now, the second thing would be security systems. Edge computers generally have less security compared to cloud computers, in the sense that each edge computer is not as secure as the entire unit of cloud computers. However, as system, edge computers are still far more secure, simply because edge computers aggregate data and distribute data among the edge computers. If a single edge computer will be hacked, it will be relatively easy, because the amount of security being invested into one edge computer would not be as high as the amount of security being invested into one cloud computing system. But this all depends on the process owner. And edge computers, generally by fact, there is not much data to be hacked. There is not much data that can be hacked and data that can be salvaged. On top of that, if you would have some basic system protocols such as firewalls and systems like that, you can ensure that systems cannot be hacked, and you can ensure that edge computers are secure. But regardless of the case, regardless of what happens, edge computers being hacked or edge computers being less secure, edge computers as system is still far more secure compared to cloud computers, because if one edge computer is hacked, the amount of data being leaked out is still not as much as any cloud system being hacked. Because if one cloud computer is being hacked, the entire system is being leaked, all data is gone. Any edge computer, if your process owner is kind enough and has a lot of money, he can easily invest in a lot of security to ensure that that computer is secure. Now, the other thing would be 3 things actually. Cost. So you need a lot of cost to invest in it, you need a lot of cost to maintain it, a lot of cost to make sure that it can operate in an environment, because you're operating in a factory environment, you're operating in a remote environment, and you are owning the computer itself. As compared to cloud computers where it's centralized, you have systems on the ground, which means you need to outright buy it, which will mean an initial investment cost which is relatively high. And then you need teams in place to ensure that you can come fix system in case anything happens. And then The computers are in a factory, so of course, regardless of whatever clean room you put it in, there will be dust, there will be systems, there will be some things that come up with the computer, and you need to maintain it. However, this can all be fixed simply by the fact that edge computers can offset the cost of the initial investment as well as maintenance and operation, because it can optimize systems. You can save resources, and this is proven time and time again through various research reports. On top of that, if you were to train in-house teams, and if you have clean rooms, a proper clean room, a much more efficient clean room designed to your factory needs, you can reduce the cost of hiring teams to come in and fix computers if they're down, or reduce the maintenance cost because it's grind getting into the computer. The last thing will be storage. Because you're physically owning an edge computer in every line, you need storage space dedicated to it. This is something that most process owners can't have because of limitations of factory space. However, depending on your factory size and depending on specification, future factories will be able to accommodate it simply because they can either build space for it, or because storage is becoming much more compact nowadays, this will not be a problem in the future. Any old factory will be able to accommodate edge computers, but any factory right now that is technically a modern factory will be able to accommodate edge computers because it is modern and there is space allocated for edge computers. So these are all cons, and these are all can be overcome simply by simple workarounds. So moving on, what is the applications of edge computing? Let me correct that. What is the future of edge computing? Where to next? It's quite simple. Edge computing is all around us and it's already being applied. We are in the future right now. Now, the 5 key applications are listed down here are smart cities, manufacturing, healthcare, AI, and AR devices. Simply put, edge computers can be used in smart cities to detect, such as where COVID hotspots are, where someone has walked, where any infectious people are, any people that need to be contacted and tested. In manufacturing, in production lines, where you need to make sure that your production line capacity and your production and your materials are all in the most optimum setting possible. In healthcare, where real-time solutions and real-time data processing is needed, we need to make sure that the patient's life is being taken into account, and you need to make sure that whatever data is being processed as fast as possible to save the life of the patient, to make sure that whatever that you're sending out is coming back to you and you're getting valuable input. And the last 2 things would be AI and AR devices. Edge computing not only complements AI, AR as well as 5G, it is able to supplement it as well. It's able to make it function to its core. Because if you would have a computer which is on site, you are making sure that it is reliable. You're making sure that you can have instantaneous, real-time decision making without relying on an external source such as cloud computing. So it's very abundantly clear how edge computing is already a part of our world, and with manufacturing students and with mechanical students coming into the world, and they learning about edge computing and they applying edge computing into businesses, you will see much more further applications of edge computing. You'll see much more advances in this field, and you'll see really unprecedented instances of how this can be applied and how it can improve our daily lives. As you can see in all futuristic movies where there are a lot of different systems working up. Edge computers will make that possible. Edge computers will make the future a reality. Edge computers will make the entire future dreamlike. We can go back to the world where we can dream about certain flying cars or tablets which are transparent and it can move around, such as in the Iron Man films. We can dream about the world simply because of edge computers. Now, with that, I would like to sum up real quick. Edge computers are the future of society. Edge computers are the system which society is going to rely on, and that we need to study and we need to place a bigger focus on. And if we do not pay attention and do not focus on that, we'll get left behind. And it's really crucial that every student and every person in this industry pays attention to what's happening to edge computers in the next decade. It's important that we try to apply edge computing and we try to adapt to edge computing as fast as possible. If not, we are going to be left behind the dust, just like how certain people were left behind in the .com era, or when left behind when computers came about. We need to make sure we stay ahead of the curve and make sure we can apply this technology into businesses, into making sure that human lives will be better in the future, and that we as a species can continue to exist in a much more comfortable and a much more idealistic life. Thank you.